Hello everyone, welcome back, and for today's video we're going to answer some exercises relating to simple harmonic motion. So let's get started. So here, the objective here is sketching and interpreting graphs of simple harmonic motion examples. So imagine that we have this graph, the displacement versus time for a 2.5 kilogram mass on a spring having a spring constant K, which is 4 Newton per meter, is shown in a sinusoidal graph. The first question is, find the period and frequency of the motion. We already understand that the period is the time it takes for one wave to complete a complete cycle. So here we can see here that this is measured in millimeter and this one is measured in milliseconds. So we know that the period, as I said, is the time for a complete cycle. So here we have the period, which is 6 millisecond, or 6 times 10 to the negative 3 seconds. So it's just fairly easy, right? How about for the frequency? We know that the period is inversely proportional to the frequency. So that means that F is equal to 1 over T, or equal to 1 over 0.006, and that is equal to 170 Hertz. And you know that Hertz is the SI unit for the frequency, the unit for frequency. Find the amplitude of the motion. You understand already that in this line, this is the equilibrium position, and the amplitude is the measurement from the equilibrium position to the highest displacement. And in this graph, this shows that the highest displacement is 2 millimeters. You notice that this one is millimeters. So make sure that you also consider writing the unit. It can be measured in 2 millimeters or 2 times 10 to the negative 3 meters. Because most of the students are just looking at number 2 and then they would just write meters, wherein it's really just a careless mistake. Let's proceed. So sketch the graph for position versus time for the situation where the amplitude is cut in half. Again, the amplitude is cut in half, but you know that the period is independent of the amplitude. This is what I said in the main characteristics of simple harmonic motion, wherein the period is independent of the amplitude. So if this is cut in half, the period will still be 6 milliseconds. We can have this as the red wave, and that means that from 2 millimeters, it became 1 millimeter. But still, the period is 6 milliseconds. Now we have another condition. There is a blue graph that is put here. Shows an equivalent system in simple harmonic motion. What is the phase difference between the red and blue wave? We know already the formula here. So the formula here is we need to check first what is the period. The period is 6 milliseconds. We know that. And the difference here is, for example, we have here from 0 to 1, from 3 to 4, we can see here the difference. So we can use this. So the difference here is 1 over 6 times 360. So the answer here is 60 degrees, or we can also express that into rad, which is 2 pi over 6 or pi over 3 rad. That will be all for this exercise, and I will continue on for the next exercises.